Hey everybody, what's up? Mr. Miller here, and as always, I hope you're doing absolutely fantastic today. In this video, what I'm going to do is review for the exam to help prepare for the exam that's tomorrow, Friday, April 20th. Today in class, we did a Kahoot review game. After each problem, I kind of quickly went through why the answer is what it is. In this video, I'll be able to take my time and specifically, what we're going to do is we're going to take problems directly off of A7 Review for Exam 1, the sheet that I gave all of you before you left class today. The way that you're probably going to get the most benefit out of this video is before you watch me work out the problem, to pause the video, work it out for yourself, and then check to see if your work matched mine. Even if you just follow along and write stuff down as I do it, I mean, you're still going to get something out of that, but probably not as much as you would if you try the problem out on your own first and then check your work and answer against mine. Okay, what's going to be on the exam tomorrow? So there are three big topics: solving exponential equations, factoring polynomials, and simplifying rational expressions. Now, factoring polynomials and simplifying rational expressions really go hand in hand because you can't simplify rational expressions if you can't factor polynomials. So if you're good at simplifying rational expressions, then that means that you're good at factoring polynomials. All right, now, the exam is 10 problems, so it's a little bit shorter than the review. There will be one application problem on there, compound interest. On your review, that's number 11. And we're going to have to really book it tomorrow. So you'll come in, please do the launch problem right away. I'm going to collect the launch problems, and I'm going to pass out the exam. There won't even be any time for me to take questions because of this modified schedule. We only have 40 minutes, and you're going to need all that time most likely to get the exam done for the average person. Some of you work quicker than others, but I think you guys are going to do really well tomorrow. So with that said, let's just go ahead and dive right into it. So taking a look at A7, the first problem that I thought I would work out for you is number 1. Right now, I am still a little under the weather. I have a cough, so if I'm coughing, I apologize for that in advance, but each time I cough, to save time, I'm not going to apologize each time I do it. Let's take a look at number 1. Number 1 says solve. It's an exponential equation, and what we're given is -4 times 7 raised to 7x minus 2 equals -74. All right, so the first thing we want to do, if you go back, if you were to look at your notes, one of the steps that I said to do was, step 1 actually, is to isolate the thing that has the exponent, the variable. All right, we need to get that thing that I just put in yellow by itself. Now, what's stopping that thing in yellow from being by itself? It's this pesky -4 that's multiplying. To undo the multiplication, we're going to divide both sides by -4. 9 to the 7x minus 2 is going to drop down, and -74 divided by -4 is what? Let's see, 37 over 2, so that would be 18.5. All right, so step 1 was to isolate the thing that has the variable, the letter. We've done that. Step 2 in our process was to now we have to free our exponent. It's being held hostage by this 9 right now, and we need to free it. How do we liberate our exponent? We liberate by logging. Liberate log, liberate log. We'll start with L. And it's fun to say, liberate log, liberate log. So we're going to log both sides. And when we do that, we can now apply that property of logarithms that says if I'm taking the log of something and that something has an exponent, I can slingshot that exponent down in front of my logarithm. Now I have this. 7x minus 2 has been freed from that evil 9 that was holding it hostage. 18.5. And that allows us to now start moving stuff around to eventually get x by itself. Now, we want to move stuff away from x. So our next step is basically to take stuff that is on the same side as x and move it to the other side. Before we start messing with the stuff in parentheses, let's get our logs on the same side. So to get rid of this log 9, I'm going to divide both sides by log 9. Okay, with me so far? When we do that, it's now calculator time, right? I don't know what log 18.5 divided by log 9 is. I'm not that good. I'm good, but I'm not that good. So what we need to do is punch this out on a calculator. Calculators, the ones that we have in the classroom, I've demonstrated how to properly enter something like that in. If you're using a different calculator and you don't get the same answer that I get, one of the issues might be is where you're placing parentheses. For instance, in some calculators, when you punch the log button, it'll do log and then an open parenthesis. You would then type in 18.5, but most people that I've seen forget to close off the parenthesis after the 5. You have to close that parenthesis off. Otherwise, you're going to be taking the log of 18.5 divided by log 9. So the calculator would interpret it as take 18.5, divide it by log 9, and then take the log of whatever that is. That's not what you're trying to say to the calculator. What you're trying to say to the calculator is take log of 18.5, get a number, then divide whatever that number is by log 9, and that will then give you the overall result. All right, so let's see what my calculator says. 18.5, I'll log that sucker, divided by 9, log it, hit equals to get the final result, and what I get is 1.3279. All right, now if you're getting something different, what you're probably doing on your calculator is this. So what I'm trying to show you is what might be on your calculator screen. You have 18.5, then you did the divided by log 9, and then you either closed the parenthesis off or you didn't. This right here, that is wrong. That is not how you enter it into the calculator. In the calculator, if you have a screen that's showing you what you're typing in, you want it to look like this. Close off the parenthesis, divide by log 9. Okay, do you see the difference there? That's kind of sloppy, sorry about that. Okay, try to clean that up a little bit, make it a little bit more presentable. Decimal point. Okay, that's a little bit better. Okay, so now what are we going to do to start getting our x by itself? The next thing we would do is add 2 to both sides. That's going to give 3.3279, and then to shine it off, divide both sides by 7. And let's just do that. Quick flick of the wrist on the calculator. Divide that by 7. And in the directions, it says to round to the nearest 10,000th. That means I want 4 numbers after the dot, following proper rounding rules. I get 0.4, 7, 5. 4 is going to stay the same at the end because 4's neighbor is a 1. If it's 1 through 4, we keep it the same. If it's 5 or more, we round up. Okay, final answer. There you have it. Okay, let's go to another problem. Our next problem is going to be problem number, let's do number 3. 3 will go very fast. 3 says factor each completely. Okay, the directions for 3 through 6 say factor each completely. So 3 says x squared plus 3x minus 18. All right, it's quadratic, it's naked, so we need to find 2 numbers that multiply to the back end, but those same 2 numbers add to, to the middle bun 3. By the way, it's naked because there's a 1 in front of the x squared. That's what makes it naked. Sorry. I broke my promise. I said I wasn't going to apologize for coughing, but I actually bumped the mic trying to move the microphone away. It didn't work. Okay. What two numbers multiply to negative 18 but add to positive 3? 6 and negative 3, yes? X squared is going to break up as x and x. These two numbers are going to drop down. Positive 6, negative 3. Or you could do x minus 3 in the first parenthesis, x plus 6 in the second parenthesis. It's the same answer. The answer would be equivalent to what I have on the screen. All right, so there will be some straightforward factor this, factor that type problem. So with that said, let's do another factoring one right quick. Let's take a look at number 4. All right, I get 8m cubed minus 12m squared minus 20m on my paper. I hope that's what it says on yours. And the directions are still the same, factor each completely. So let's first notice that this is not quadratic. This is something other than quadratic because the highest exponent on the letter is 3. That's not quadratic. That's a red flag that we should hopefully be able to take some stuff out. Meaning, let's find what the GCF is. All right, and just very quickly, let me toggle back to number 3. If your thing that's given to you is naked, the GCF is automatically 1. So that's why I didn't bother to talk about the GCF on number 3, because I had already mentioned that in class, that if you're given something that's naked, the GCF is automatically 1. But here it's dressed, all right, because there's a number in front of the highest term. So we've got to check now to see if it has a GCF other than 1. What's the biggest number that goes into 8, 12, and 20? All right, now, if you're not sure what that is, rather than kind of enter a stall or get frustrated, list the 3 numbers out in front. I'm ignoring the sign because it's not really important right now. And list all the ways to multiply to get those numbers. 8, 1 and 8, 2 and 4. 12, 1 and 12, 2 and 6, 3 and 4. 20, 1 and 20, 2 and 10, 4 and 5. Now you compare the 3 charts. What's the number that's the biggest? That's the same to all 3. Are you thinking 4? Fabulous. 4 is correct. Very good. You are wise. All right, so our GCF starts off with 4, but can we take out some letters? I wonder. I think we can, right? How do we make that decision? Doesn't have to be a mystery, doesn't have to be guesswork. The problem tells you how many letters to take out. Look at your exponents. This is m to the third, this is m to the second, this is m to the first. We always go with the smallest exponent. So we can take out what? Well, 3, 2, 1. 1 is the smallest. We can take out a single m. When we do that, okay, 4m, open parenthesis, and now let's see, when we take that 4m out, how does that change our problem? Let's see, what would I multiply 4 by to take me back to my 8? That would be 2. Another way to do it is this. Instead of trying to figure out through multiplication, use division. 8, start with the original, 8 divided by my GCF 4 is 2. Now for the letters, I like to do this. We start with 3. We're taking 1 out. That's going to leave how many? 3 minus 1 is 2. Okay, put down the minus. What do I multiply 4 by to take me to 12? That's 3. Or you could use division. 12 divided by 4, bam, still 3. Haha, savage. 2 m's, we're taking an m out. How many m's would be left? A single m. What times 4 takes me to 20? That would be 5. I had an m, I took that m away, now I have no m's on that back end. Are we done? Oh, I wish we were, right? But I don't think so. We might be able to factor this quadratic that's inside our parentheses now. Now, is it naked or dressed? It's dressed, right? Because there's a 2 in front of the squared part, right? There's a 2 in front of our m squared. That's bad news for us in a sense because we're going to have to use that stinking table unless you have a different method of factoring that you like guess and check, which I really don't care for, but if it works for you, you may use it. All right, and I'm going to clear some space. Need space. All right, so let's worry about this quadratic now. Oh my god, the video's already 15 minutes. You guys are going to kill me, aren't you? All right, 2m squared minus 3m minus 5er. Okay, minus 5. So we got to do front end times back end. Two times negative 5 makes negative 10. Now I need two numbers that multiply to negative 10. Multiply to negative 10, but those same two numbers have to add to the middle bun, which is negative 3. All right, now what the heck? What two numbers multiply to negative 10 but add to negative 3? How about negative 5 and positive 2? Now, how did I get those? One reason is I've been doing math for so long I can just kind of look at it and see what numbers make the magic happen. But when I was first learning how to do these, it was a struggle. So here's a technique that might help you figure out what these numbers are. You're trying to multiply to negative 10. Let's ignore the negative for now. On the side, list all the ways to multiply to get 10 using whole numbers. 1 and 10, 2 and 5. And that's it. Those are the only you only have two pairs that are going to make the magic happen, and only one of them is going to work. Now, to determine the winner, which one is going to get you to 3 or negative 3? Let's say you want to ignore the negative for now. You're just trying to find the pair that's likely to work. So let's say you ignore the negative. Well, 5 minus 2 is 3, so we're heading in the right direction. It seems logical that it would have to be this pair. All right, so 5, 2, we would put 5 and 2 down, and now you have to decide where is your negative going to go. You want to end up, when you add, with more negatives than positives. That means the bigger number is going to have to get that negative. All right, now what if this would have been positive 3? The signs would be flipped, right? If this is still negative 10 and that's positive 3, you want more positives than negatives, so you would put the negative on the smaller number. Okay? Hopefully that helps a little bit. Now, what time is it now? It is table time. Woo! Good times. Table time. All right. Table time. Always a good time. So first box, first piece. Last box, last piece. And then along the diagonal go our two numbers. Okay, right? Negative 5, positive 2. And then to each of those we glue the letter. All right, now this part I'm going to blaze through. All right, the GCF of the first row, M. GCF of the last row, positive 1. Remember, we always take the sign directly to our right or directly below us. GCF of the first column, 2M. GCF of the last column is negative 5. Why is it negative? Because the neighbor directly below us is negative, so that means I'm negative. What we just found is how the 2m squared business here inside the parentheses factors. The 4m, easy to forget about. Don't do that. Don't leave your child at the mall. That 4m is still part of the answer. Don't treat it like it's some kind of redheaded stepchild or something like that. You still need to include the 4m in your answer. 2m minus 5, m plus 1. Or if you have 4m, m plus 1, 2m minus 5, that's still an acceptable answer as well. And so I'll put the final answer in the red box. And there you have it. There's our answer. All right, you guys are doing great. We're going to do maybe 1 or 2 more problems, and then we're going to bring this video to a close. The next problem that I thought we would work out is, let's take a look at number 8 together. All right. And number 8 says this, at least on my sheet. I have 10a to the 4th. I hear people out in the hall. I hope they're not coming to knock on my door. I'm trying to record. All right. Plus 34a cubed minus a 24a squared all over 6a cubed plus 33a squared plus 36a. All right, so this is a simplify rational expression type problem. This is what we have been practicing all week this week. This is where your factoring is really going to come in handy, because if you cannot factor, oh, heaven help you. It's just going to be a rough next couple of weeks. I don't want to see you struggle like that. So if you are still struggling with factoring, you really need to come and see me and get some extra help. 10, 15 minutes after the day ends. Doesn't have to be long. Come and see me. All right. I already made this speech in the last video I did that I posted to YouTube. All right. So the first thing that we need to recognize is this is not the quadratic, right? Because the highest exponent is 4. Quadratic would mean highest exponent is 2. Same thing here in the downstairs. Check that out. Highest exponent is 3. That's not quadratic. So that's a problem, but it's also a sign that we have some GCFs that we're going to need to take out. Okay? So if you're looking at something that's not quadratic or it's not linear, meaning the exponent, highest exponent is 1, that means that you're likely going to have to take some stuff out. Now, the GCF could be 1 when you're comparing the numbers in front, but that doesn't mean you should stop there. You also need to check to see if you can take any letters out. So what's the biggest number that goes into 10, 34, 24? Did you say 2? I think you did. And kudos to you, that's correct. Now, how many letters can we take out? Go with the smallest exponent, 4, 3, 2. We can take out 2 a's. So in other words, that means a to the second power. How many factors of a can we take out? We can take out a squared. 2 factors of a. All right. Now I'm going to do this really quickly. If you're still struggling with GCFs, then on the side, if you're not sure how I got 2, it doesn't have to be a mystery. List out the 3 numbers in the problem. 10, 34, 24. Well, that looks like 3y. That sucks. Sorry. 4. Kind of make it block style. There we go, 34. All right, what are all the ways to multiply to get 10? 1 and 10, 2 and 5. All the ways to multiply to get 34. 1, 34, 2, 17. That's it. Okay, 24. This one's going to have several factors. 1, 24, 2, 12, 3, 8, 4, 6. Now, we take a step back and we look at all 3 charts. What's the biggest number that is common to all 3 charts? It's 2, right? That's why the GCF of 10, 34, and 24 is 2. Now, you want to get to a point where you don't have to do this every single time because it takes time. And exams are pressured situations because time is limited. So if you need to do it for now, that's great. I do it because it's going to get you the right answer. But eventually you want to get so good you don't have to fiddle with this kind of list all the factors and find the right one. All right, so we're going to take out a 2a squared on the top. And when we take that 2a, oh my God, 24 minutes. When we take that 2a squared out on the top, what's going to be left? We're going to get 5a squareds plus 17a minus 12, right? All right, now let's do the GCF of the downstairs. GCF of the downstairs is what? What's the biggest number that goes into 6, 33, and 36? If you're thinking 3, You're right on target. Good job. How many A's can we take out? Always go with the smallest exponent on the letter. You can only take out a single factor of A. So our full GCF is 3A for the downstairs. Now, let's see what shakes loose when we take out 3A. When we take out 3A, we're going to be left with 2A squareds plus 11A plus what? Plus 12, right? Okay, and in previous example and in class, I have already demonstrated how do you get this once you find the GCF. I'll do it really quickly here. What times 3 takes me to 6? 2. I had 3 A's, I took 2 out. I had 3 A's, I took 1 out, so that leaves 2. What do I multiply 3 by to take me to 33? That's 11. I had 2 A's, I'm taking an A out, that leaves a single A. What do I multiply 3 by to take me to my 36? That's 12. I had an A, I took an A out, that leaves no A's. Now, please seriously pause the video, because for this example, since I already showed how to factor quadratics in a previous video, and I showed how to factor some quadratics in this video, I don't want to waste, I wouldn't say it's a waste of time, but I don't want to add this time to the video because I still want to work out one more with you after this. So pause the video, factor, and cancel, and then when you hit play next, what you're going to see is the work and the answer, and hopefully it matches with what I got. Okay, please pause the video right now, work it out. Okay guys, check it out. So after I factored the quadratic that's in the upstairs, the 5A squared business, and then I factored the 2A squared business in the downstairs, my work for that is shown over here on the left. The top quadratic factored as A plus 4, 5A minus 3. The bottom quadratic factored as 2A plus 3, A plus 4. If any part of this can be fun, it's the canceling part. You're going to go in like Han Solo with a lightsaber and just start canceling stuff out. You're going to annihilate stuff. Factors that match we can cancel. A plus 4, they go bye-bye. A squared means I have 2 A's glued together by multiplication. Those are both factors. I can cancel one of these 2 A's with the A that's in the downstairs. So that means at the end of the day, that A in the downstairs is now gone, and I only have 1 A in the top now. I started with 2, A squared. That's 2 factors of A, but I end up with 1 because 1 factor of A canceled with the A in the downstairs. Okay, I hope that's clear and that's helpful, and we are almost finished, guys. What we're going to do now is big finish. Let's do number 11 on the sheet, because there will be a problem just like that on tomorrow's exam, and I want to make sure that you're up to scratch on how to do it. I think I included the actual text in one of the sheets. Yeah, here it is. Okay, so the problem says calculate the minimum amount of time it would need to take to accrue $500 interest if you placed $2,000 in a savings account that has an interest compounded annually at an interest rate equal to 4.125%. Round to the correct whole numbered year. Our final answer is not going to be a decimal. We're going to express it as a whole number. All right, so let's get right into it. I'll provide the formula for you on the exam. You don't have to have that memorized, but I'm trying to get this out of the way. The formula is this. A equals the principal, and then inside we have 1 plus the interest rate, and then all of that is raised to the t. T means time. Now, we're putting in $2,000. We're going to let it simmer for a while, and we want to come back to our bank account. We want to go back to the bank when we have $500 in interest earned. What we want to know is how long am I going to have to wait and let that money simmer, let it stew, before I'll have $500 interest, all for just depositing the $2,000 to begin with. If we put $2,000 in and we collect $500 in interest, how much money would we have total? We would have $2,000 plus the $500 in interest. So our total would be, the amount of money we would have at that point would be $2,500, right? That's what our capital A is. Our capital A is $2,500. What's our interest rate? Well, they tell us that our interest rate is 4.125%. All right, now we need to convert that to a non-percent. That means we need to divide it by 100 or move the decimal point 2 places to the left. And when we do that, we get 25. All right, the time, which is another one of the variables in our problem, we don't know. And the principal is the amount that we started with. How much money did we start with? Well, that's how much we deposited, and that was the $2,000. Okay, we have all the ingredients we need to solve this thing, and once we plug these numbers in, what we're going to have is an exponential equation. We got some practice solving those a couple weeks ago. So let's start filling in our numbers, and then we'll solve this sucker, and we'll call it a day. Our capital A is 2,500. The amount of money that we dropped in to the bank account was $2,000. Now, I have to add 1 to my interest rate. When I add 1 to it, this 0 in front is going to become a 1, right? 1 plus 0.04125 is 1.04125. All right, 1.04125, and this is to the t power. And that's what we're trying to find, is what t is. All right, it's an exponential equation. So what I need to do first is I need to get the thing that has my variable by itself first. I'm going to highlight it. How am I going to get that thing in yellow by itself? Well, I need to get rid of that big bad 2,000 that's to the left of it. So we're going to divide both sides by 2,000. Okay, that's nice and good. These zeros are going to cancel out and cancel ending zeros and pairs. Let's see, 25 over 40, that's 5 over 4. So what we get on the left, if you were to just divide that out on a calculator without going through all that canceling business, it should be 1.25. Okay, and the only thing that happened on the right side was the 2,000s got canceled because we divided both sides by 2,000. Now what we need to do is liberate our t. Our t is being held hostage by the 1.04125. How do we liberate it? Liberate log. Liberate log. We want to liberate our t, so we are going to log both sides. All right. So here is log both sides. Log 1.25 equals log 1.04125 to the t, and when we log both sides, this exponent we can now slingshot down in front of our logarithm, and that's going to allow us to solve for t now. Equals, I'm going to have to clear some space. Sorry for that, but I need room. Otherwise things are going to look too cluttered. Okay. So now we have t times 1.04125. All right, we're almost there, guys, right? We're almost there. Hope is in sight. Light at the end of the tunnel. I want to get t by itself. I need to get rid of this log, blah, 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 1.04125. So I'm going to divide both sides by it, right? That would be our next step, to get our logs on the same side, moving stuff away from the variable, the letter. 125. Now for the good news. The calculator is going to do the rest of the work for us. Oh, sorry. Microphone grazed my collar. My bad. All right, in the calculator. So it's top to bottom. I enter the top in first, and then I do the bottom. 1.25. Log it. Divided by 1.04125. Log it. If you stop there, you're going to get the wrong answer. Why? Because what the calculator is showing you at most, well, on the calculators that I have in my classroom that a lot of you use, what it's showing you is what the log of 1.04125 is. And the calculator right now says 0.01755, blah, blah, blah. No. We want to know what is this whole thing. So to get that, we hit equals. And what I'm getting is this. 5.5, okay? Now, for problems such as this, it does not matter what kind of decimal you get. We're going to violate normal rounding rules. If I would have gotten 5.1 or 5.3, I would still round up to the next highest year. So no matter what on these problems, I'm going to put it in red and in capital letters. Always round up. Okay. Always round up. So this is like my exclamation point up arrow mixed together. So what would be the number of years? Whole number year would be 6. T equals 6. All right. Okay, guys, that's all that I have for you. I hope this video has been helpful. Feel free to email me questions if you're still stuck on something or if I made a mistake in the video. And I look forward to seeing you guys tomorrow. Keep up the great work. Tomorrow's Friday. Keep smiling. Bye-bye.